Okay, so quick mechanics question. An empty minecart of mass 10 kilograms can be filled with coal, which can then be transported along a horizontal shaft track. The effective coefficient of dynamic friction between the cart and the track is 0.6. 0.60. If a stationary cart is filled with 100 kilograms of coal, which one of the following forces might move the cart? So basically here we have a cart which itself has a mass of 10 kilograms. However, I'm putting more stuff in it, 100 kilograms of coal. So the total mass, let's call it uppercase M, would be 110 kilograms. Right? If this cart is on the floor or on a track, as the question is telling us, right? If we draw a free body diagram, what would we have? We would have a force downwards, which is our weight. In this case, let's use uppercase M, since we're taking into account both the mass of the cart and the mass of the coal, which is inside of it. And we will have some normal force. If the cart is not going up or down, so, well, if it's not accelerating up or down, those forces would be in balance. So we could do sum of the forces in y will be equal to 0. Therefore, the normal force will have to be our gravitational force. They will have to have the same absolute value. Opposite directions, but same magnitude. So, if we calculate our normal force, it would have 110 kilograms multiplied by the acceleration of gravity, which is 9.8 meters per second squared. Okay, now if we multiply those numbers, if we keep two significant figures each, we would actually have a 1078 newtons. Okay, this is a unit symbol, it's not normal force. Now, if we're being consistent, we would have to round this number to two significant figures, since we only have two significant figures here and two here. So this would be considered to be around 1,100. So you can see that if you consider this to be 10, you would even reach a quite reasonable number, quite close to the one that you were looking for. Now, why did we calculate the normal force? Well, because friction, as we know it, is given as a product of the coefficient by the normal force. So if my block is going to the right, let's say, if I want to start moving it to the right, my resistive force, my friction force, will try to oppose that movement. So it will be to the left. Now the question tells us that the cart is stationary, so my initial velocity is 0. So if our initial velocity is 0, if the relative velocity between the cart and the floor is 0, which it is in this case, the actual friction force that we would have would not be the dynamic friction, it would be the static friction. Now, if the block was moving, if this cart was moving, we would calculate our dynamic friction to be this force, which is the normal force, multiplied by our coefficient of dynamic friction. And this would give us 660 newtons. Now, our static friction is always larger or equal than our dynamic. So, in this problem, the actual answers which were possible were the following: 685 newtons, 647 newtons, 612 newtons, and 110 newtons. Now, if my static friction has to be larger, so greater or equal than our dynamic friction, which we have calculated to be 660 newtons, the only answer which is larger than 660 is this one. So we know for sure that this is the only possible force that would be able to perhaps move that cart. To know for sure, we would need to know our static friction coefficient. However, since we don't have it, the only possible, if we're told that one of those forces is going to move that cart, the only one which is reasonable to assume to do that is this one.